Hello and welcome to part two of RStudio for Windows. In the first episode, we installed RStudio for Windows and I gave you a quick tour of what it looks like when it starts when you first open it. And today we're going to be opening a program, opening the text editor and looking at how to write a very simple program. We're going to declare a variable and print it out, and then we're going to declare a vector, and then we're going to print it out. And today we are going to learn some syntax to do some basic operations using the R system. Um, what is syntax? Basically, we're just going to learn computer grammar. Syntax is another word for the rules of grammar. Um, the system which holds the computer language together. Unlike human language, computer language has to be really precise. With human language, you can have some ambiguity, you can have some error, and the person you're talking to will understand what you mean. But with computers, the instructions have to be very precise. So you have to pay attention to the rules of syntax and how you put together computer commands so that the computer understands you clearly. And with R programming, we are going to um, use variables, just like with an algebra expression. In algebra, you declare a variable and then you assign a value to it. Remember, x equals 2 and y equals 4 and x plus y equals 6. It's the same thing with computers, and you continually, as your programs get more complicated, your variables change, and it allows you to create long strings of operations. You'll learn all this, but as long as you remember the basic concept of variable from algebra, this is very easy to apply to computers. Today we're going to declare some variables, assign a value, operate on the variable, and output the operation on the variable. Then we'll save the program so we can reuse it. We can assign different variables the next time to our program. And imagine we want a program which figures sales tax. One day the sales tax is 6%, so our variable for sales tax is 6%. And if the sales tax changes, you can change, if the sales tax changes to 8%, it's just a matter of changing the variable to 8%. Reusable, changeable. Um, like I said, it's just like algebra. Um, and we have to remember to use the rules of syntax to properly change variables when we need them and operate on them in a logical way so the computer works in a predictable manner. When you name variables, you do have to be a little careful because the computer uses what are called reserved words, which are words the computer uses as code commands in the computer language. Um, so to, to prevent any um, confusion, I always use a person's name for a variable. That way it sticks out and it's clear that it's intended to be a, a variable, uh, not a regular uh, expression that the computer uses as an instruction. Um, these are some reserve words here. You know, you don't want to name a variable print or something like that. You don't want to try. It will give you an error message anyway. So, and sometimes computer language gets complex, so it's kind of important when you're beginning to make it clear what variables are and what computer commands are. So I just use names. Later on there, you'll learn naming conventions. But you can use any name that you wish, and that's a great way to prevent confusion. Okay, in algebra, when you assign uh, a value to a variable, you use the equal sign, but in R, we use an arrow pointing to the left. It's um, the key next to the M with a little uh, left-hand angle bracket, followed by um, the key above the P, which has the hyphen. Um, and so it's angle bracket hyphen, and that works as an arrow, and that works as an equal sign in R. So here's the syntax. Here's the rule of grammar. Here's what it looks like. The variable name, arrow, value. So imagine we have a variable name Hamlet, and we assign it the value 65. We go to the text editor, and we type in Hamlet, angle bracket left, underline or hyphen, and then space 65, and we've assigned 65 to the variable Hamlet. So let's do this in RStudio and see exactly how it works. Remember, we go to RStudio in the windowing environment. We go to the upper left-hand corner where there's the File menu, and we select a new R script under the using the File menu, and then a text editor opens up in the upper left-hand corner, and we enter this. We'll show you what it looks like in the next screen. We enter the text Hamlet, space, angle bracket, angle bracket hyphen, space 66 for Hamlet equals 66. That will declare the value of 66 for Hamlet. I'm going to go ahead and then we're going to print Hamlet out using the print command, and that will echo back the value of Hamlet to us. It won't print out the word Hamlet, it will print out the value of Hamlet, which is 66. So the two bold-faced bits of text right here is what we're going to type into the text editor in the next screen. And then we press a button called the source button, and that will run the program and spit it back to us. Now, if you remember, to open the text editor so that you can write a program, you select New File, R Script from the file editor. Don't select Project. And only then does the text editor become visible so that you can type in programs. See, we've opened the text editor. Again, using File, New File, R Script. And then text editor opens, we type in Hamlet, arrow hyphen 66, and then print Hamlet. And bottom half of this screen, you'll see 66 prints out. That's the output from our command print Hamlet after we've assigned 66 to the Hamlet variable. And remember, we press the source button after entering the text, and that runs the program. Again, looking at it more closely, Hamlet, arrow hyphen 66, and then print Hamlet will print out the value. Okay, so that's pretty simple. Now we're going to work on a little group of numbers. We're going to give the group a variable name, and then we're going to enter in the group of numbers, and then we're going to print it out afterwards. A group of numbers in R, you're going to be working with groups of numbers a lot. A group of numbers is called a vector, um, and you declare a vector by declaring a little group of numbers, and you put a little c in front of the parentheses. C stands for concatenate, which means assemble. So we're going to create a vector with the variable name Reynard, and um, just like when we created a single value variable before, Hamlet, uh, this one is going to be Reynard. But instead of a single value, we use the little C command for concatenate, um, and then a group of numbers after each followed by commas. And just like with handling a single variable, Hamlet, you can handle Reynard in exactly the same way, except it's going to print out or return or operate on a vector, a group of numbers. You just refer to them by the name Reynard. Now, in this instance, I've uh, capitalized Reynard. You don't have to. I just did in this case. You'll notice the previous case I did not capitalize Hamlet. Um, the the thing is, however you decide to capitalize or not capitalize a variable name, you have to be consistent, um, because R is case sensitive when it comes to variable name. Also notice, this is an important thing to notice, the little arrow. Um, you would expect maybe that the arrow would go the other way because in English, in Roman uh, letters, in Romance languages and in European languages, we read left to right. In this case, the arrow goes the other way. That's called right to left. That's right to left syntax is used in certain parts of R. In other parts of R, you read left to right. Um, right to left syntax is used to assign variable values. Um, it's just you're going to have to. That's how it works. It's the equivalent of an equals sign, but you have to remember the arrow points the opposite way in which you would ordinarily read or read a mathematical equation either. But it has to do with the programming logic uh, by which R runs. So you just have to be used to the fact that sometimes syntax runs right to left. Okay, so what we've done is we've created the vector Reynard. We've named the elements of it and put them in parentheses, and when you precede them by a C, that creates a vector structure, and we named it Reynard. And then we press the source button. Now we did not put a print command in this particular example, no print Reynard, um, but we do get a return in the console. All we get is that little language in blue, which returns the name of the file, the name of the R script, and where it sits. It's just a little throwaway script that I saved on desktop, and I misspelled the name example. You'll notice it has a suffix R. Um, when you have to enter the print command or some other type of command that manipulates the data before you'll get any kind of return of the data. In this particular instance, all we did was create the vector. And the fact that you didn't get an error message and you just got a return of the name of the file, the computer tells you nothing except that absence of an error message shows that the computer accepted your variable and that the rules of syntax were not violated by your vector declaration. um, but you're not getting any output because you didn't put in an output command. Now let's print out Reynard. Type print Reynard after Reynard and hit the source button again, and you'll see the output of the 4 values of the vector Reynard. So we just created a vector and printed it out. So now let's operate on that vector. Let's find the average of the items inside the vector. To do that, we use the mean command. We're going to operate on a variable with a variable which is a vector with the name Reynard, and we just type the command mean and Reynard inside parentheses, and then we assign that all to a new variable name, Luitpold. Luitpold is the variable which will hold the value which is the mean of the vector Reynard. And of course, this is all right to left, right to left logic. So the arrow goes to the left. And so we have a variable whose value is derived from the mean of another variable. And that variable has which is a vector, has four members to it. So it's getting a little complex. But you treat Luitpold just like you treat the variable Reynard or the variable Hamlet. You can print it out, which is what we're going to do. This is what upper left is what it looks like when you type it into the text editor. And the bottom right is what happens as it prints out. So you have 4 lines of text with 2 commands in the text editor. First line, of course, you concatenate 4 numbers, and you assign them the value Reynard, and then you print out those 4 numbers by commanding Reynard to print out. Next, you assign the value of the mean of Reynard to the variable name Luitpold, and then you print out Luitpold. So you have 2 print commands, which means you have 2 printed lines of numbers in the console below. 5.5, of course, is a mean of 3, 5, 7, and 7. What we did is we built those 4 lines of code over 2 separate slides. And so the first command to print out Reynard printed out Reynard again the second time because the command was still active. Imagine, this is just an aside, but imagine all of a sudden you only want to print out the second line. You only want to print out the value of Luitpold. You don't need the value of Reynard anymore. You can block the computer from continuing to print out Reynard at any future time that you push the source button by putting a hashtag in front of the command print Reynard. Putting the hashtag in front of any R command to the left of any R command will block it from being executed. It's just a little comment. It's called a comment, and what it means is the computer will ignore anything that has a hashtag in front of it. That's useful as you're building code because you might want to not repeat the same thing over and over again as you're building a system of commands. And of course, like we did before, you want to save your program using the file extension R. You can save it wherever you wish. But if you save it with the file extension R, when you click on it in the file finder, it will start up RStudio if RStudio hasn't been started. And you have in the environment browser a list of all the variables you have available. And later on, you'll have, as you do more advanced stuff, you'll have a number of programs open, and the programs can share variables. What this means is you can't name a variable um, that's the same across two programs that are open at the same time. So you have to keep track of the names of variables that you have assigned, but allows you to use variables from a remote program um, in your other programs. And of course, a list of your variables will remain available in the environment browser. Here you can see what I mean. That's a list of the variables we've created and a little description of them as well. Okay, sometimes you get an error message. That's not uncommon at all. Error messages come in red. Um, in this case, I entered some letters where I should have entered punctuation, and the computer um, pushed out, and when I pressed the source command button, it gave me an error, and those errors can accumulate. Those error messages can accumulate and get in your way, and your console can get very crowded. You can clean out your console by pressing the little broom icon in the upper right-hand corner of the console. Little picture of a broom. It's a little faint. It's a little grayed out, but it works, and that will clear the console to make things more neat. Okay, so just a quick summary. Um, First, we declared a variable. We gave the variable a name Hamlet, and we assigned the value of 65. Then we printed it out. We printed the value of Hamlet. So if we command print Hamlet, it will print out 65. Then we declared a vector, Reynard, again using the little angle bracket hyphen notation for arrow, and then C for concatenate, and that command will allow you to group a bunch of numbers separated by commas within parentheses, and then you have a vector, which is a bunch of numbers. And then you can operate on a vector with a function, in which case we wanted a mean of the four values inside the vector Reynard, and we named that value Luitpold as a variable. So Luitpold is the mean of Reynard, and Reynard is 4 digits, 4 numerals. And we also showed you how to use the hashtag to temporarily stop a command from being run. And then we also showed you how to use the broom icon to clear the console of error messages or just content that you don't want anymore, output that you don't want. So this is a very simple tour of how the most basic commands work in R console. We hope this was useful. So thank you for watching. A link to the next episode of this tutorial should appear right now in the upper right hand corner of this slide. Thank you for sticking with R. You'll find there's a moderately steep learning curve to start to use it, but once you do, it's very helpful and powerful tool. So keep with it, and this next episode we will learn a few more simple steps.